Hello and welcome to our first lesson in Chapter 5, Bivariate Data Analysis. And we're going to take the information that we've learned about and try to use it so that we can make future decisions and hopefully understand a system or a situation better, as well as the amount of confidence we have in finding something out. So there's the ability to make a prediction, and then there's also how confident we are, and that comes up throughout the chapter. So let's look at just a way to open with Max owns a drive-in movie theater. He collects some data about different items that they sell. Now, if Max buys the right stuff, he's going to buy enough to sell every time and not have to either throw it away because it spoils or sell it cheaper. So he wants to do a good job of accurately getting his inventory. What do you notice about the scatter plots? Do you have any conclusions? How confident are you? So if we look at this, as the temperature increases, the liters of increase sold, the liters of pop sold is going to be here. This information looks pretty predictable in terms of as the temperature goes up, we would expect we'd want to have, ice cream this is. We want more ice cream available as the temperature goes up. Now, if we guess wrong, we might have some stuff melt and that wouldn't be good. So we want to be accurate. It looks like we could be pretty accurate, but we don't have great confidence. All these points don't land exactly on a line, right? An estimated line. If we look at B here, the liters of soda sold and the number of packets of snacks, the number of the number of packets that are sold of snacks looks like it's dependent on pop. So if there's pop sold, the owner here is expecting that the snack sold will also increase, but not as confident. So we wouldn't have necessarily a strong confidence. We might have a more moderate confidence that the number of liters of soda sold as it increases. You may not be quite as confident of how many packets of snacks. And then finally over here, length of a movie and the number of viewers. It looks kind of random. We don't really see a correlation here that can be trusted. You could easily draw a line that has a positive slope or a negative slope, and you wouldn't have much confidence. So we would say there's very little correlation here. So a pretty strong correlation. We might be able to trust our predictions for how much ice cream we buy based on temperature for the forecast. Here we're less, so maybe more moderate. And finally, we really can't draw much of a conclusion in terms of the correlation for this last graph. All right, a lot of talking. Here we go. So DUFS, D-U-F-S, is going to help us describe the 4 features that you're going to be asked to explain when you see data. First identifier is going to be direction, and that's either going to be positive or negative, basically works as the slope. So a positive as x increases, so from left to right, the x goes up, the y would go up, and that's a positive slope. Negative, as x increases, the y would now decrease, okay? U stands for unusual features. This is probably the toughest of them. We have a couple of things we're going to point out. You could find other unusual features, but basically you'll see some clusters in our data, and also you'll see some outliers. So be ready to look for those, and maybe there are no unusual features, so be also ready to say there are no unusual features. We will always have a direction for our for the work we do, though. F is going to stand for form. And at this point, we don't really know much besides linear graphs. There are some nonlinear, and they have different functions you'll be learning about in second semester for sure, something called quadratics. But at this point, it's either got a form that we recognize, and we'll say it's linear, or a form that we don't recognize, and then we would say nonlinear or not linear. And then finally, S is going to stand for strength. I suggest you link direction and strength together. They're pretty tangible. The U and the F get a little bit tougher, but make sure you're really dialed in on positive slope, negative slope. That's the direction. And then the strength is a separate thing, and we'll talk about how we identify that. We've already used the term weak, moderate, or strong you'll notice that this data looks like it's got a positive direction. So does this, but this looks like it's more tightly bundled, okay? And then this one looks even more tightly bundled, but it doesn't look linear. It's still a strong connection, but we couldn't label this as positive or negative because we just don't really know what's happening there, it looks like. Finally, the features of this graph, if we look at this, lots to write down here. There is a fairly strong because the cloud of points looks like it's following what would be a line of fit pretty well. That line of fit would have a negative slope, so it's definitely a negative. And it's linear because that's our relationship we know about. It's a line of fit that would fit in there. And this relates the average daily temperature to the number of coats that are sold. As the temperature goes down, we would predict that we might sell more coats. Okay, and it doesn't look like there's any outliers. Nothing unusual is what that means. But we covered the form, which is linear. We covered the direction, which is negative. And then the strength, which we said was strong or fairly strong. All right, so we're going to go through these, and then you'll be ready for your CYUs. Looking at the length of a fish and its weight, we would guess that as the fish gets longer, its weight would be bigger. So we'd say there is a weak positive linear relationship. So that covers our positive, that's our D, and then weak is our strength. So D and S. Linear is our F, that's our form. So we've covered 3 of the 4 letters that we use. The relationship between the length and weight of a whatever kind of fish that is. There are also 2 distinct clusters, and that makes it unusual. That's something unique about this graph that we wouldn't normally see. So the weakness is the strength, the positive is the direction, linear is the form, clusters is the description of the unusual nature. Coming over to this one, take a look at it. It looks like there is a pattern there, but it might not be real strong. Moderately strong, positive, and straight line linear. So moderately strong is our strength, our S. Positive is our D, or direction, and then the form is linear. So DUFS, still have a U left. We could say that there is a possible outlier in one of these spots here, but that's the only thing that might seem unusual. Last 2 examples here, average heart rate, life expectancy for several mammals. As it looks like as the heart rate goes up, the life expectancy goes down, so their body must be working pretty hard. There's a moderately negative, and then this is nonlinear. We're going to learn what kind of function that is later, but this is definitely not a line. You could force a line in there, but it wouldn't be the best fit. So there's a moderate, negative, nonlinear relationship between the heart rate and life expectancy, and doesn't look very unusual. It looks like the graph of something that we'll learn about later as far as the form, but it's nonlinear. And then finally, grams of sugar and the rating that a cake got at a bake-off. We would assume that there's too little sugar and that affects the taste, and so they didn't score well. And if you put too much sugar. So this has it's definitely not linear, a different kind of shape. So we'd say nonlinear probably. Let's see how we could describe how close it is. There is a strong nonlinear. I don't see any data values that aren't predictable. They're not perfect, but it's pretty strong. Between the grams of sugar and the scores for cakes and the bake-off, it is neither positive nor negative because this form doesn't have a slope. And there's really nothing unusual about it other than a form that we are not familiar with. That'd be the only thing unusual. But when you learn about what equation gets us a form like this, it'll make some sense. Okay, so a lot of vocabulary, a lot of kind of big picture thinking. Work on the homework, ask questions when you get to class.